Hey everyone, it's been a week and we're ready to take a look at our seed samples to see how they've changed. So if you remember from the first part of the video, we set up two different samples of seeds. We had seeds that were being stored in the normal classroom environment. So this was our control, and these were stored under dry conditions. The other seeds that we set up were placed into the simulated burrow. So those seeds were placed inside of a 1 liter beaker that's been turned upside down. It's placed into this tray that's filled with water. The seeds are on top of a smaller beaker, also filled with water. So as the water is evaporating inside of that chamber, the humidity level is coming up, and that means that the seeds are being stored in much more humid conditions than the seeds that were out in the classroom. So let me get the seeds that were in the simulated burrow here. So move this out of the way. And here's the seeds that were stored in the simulated burrow. Visually looking at these, I can notice some things are different about the two groups of seeds. So these are the seeds stored in the dry conditions of the classroom. You can see that they slide around pretty easily inside the petri dish. And these are the seeds stored in the elevated humidity of the simulated burrow. And you can see that they're kind of clinging, right, to the sides of the petri dish. Now I need to get them out of here, so I'm going to just kind of make sure they're not clinging as much to the plastic of the dish. The seeds that were stored under dry conditions, when we measured their mass, starting the experiment, the initial mass was 5.084 grams. And then the seeds that were stored under the humid conditions, their initial mass was 5.033 grams. Now, I do need to zero this because currently this is measuring the mass of the plastic weighboat. I want to ignore that in my final mass measurement. So 0. All right, now it's reading 0.000 grams, exactly what I want. Here's my seeds stored under the dry conditions, and I'll transfer those to the plastic weighboat. And be careful I don't spill any. I want them all in the plastic weighboat, so I'm measuring the mass of all of the seeds that I started with. So some static that's making the seeds cling. So I kind of have to just get in there with my finger. I've got a couple seeds even clinging on the lid. So I'll get those over. And okay, so I did successfully transfer all the seeds. And I can see that the seed mass has actually changed a little bit in the week that the seeds have been left out of my classroom. I'm going to take a picture of this. Seeds are currently measuring. So these seeds are currently measuring 5.158 grams. So these seeds have gained a little bit of mass. I'm not surprised by that. Like I said, it's May, the humidity levels are coming up, so my classroom is more humid than if I was running this experiment in January. Plastic weighboat on the balance, zero that. And here's my seeds. Transfer these into the plastic weighboat. Okay, I got all of them. None there either. All right, now these seeds have changed in mass as well. These, I'm going to take a picture of this. So these seeds are measuring 5.645 grams. We want to figure out in this experiment if some types of seeds do a better job of absorbing water vapor out of the air. Remember, rock pocket mice and kangaroo rats live in a really dry environment and they don't have a lot of water availability. They actually don't even drink water. So they're getting the water that they need to maintain homeostasis from the foods that they eat. If they're able to select seeds that absorb more water, they're getting more water content in their food, and that is going to be a benefit to their survival. All right, let's go ahead and analyze the data here. The seeds that were stored in the humid conditions started with a mass of 5.033 grams. Those seeds increased to a mass of 5.645 grams. Now, the seeds that were in the dry conditions started with a mass of 5.084 grams, and their mass increased to 5.158 grams. So now we're going to run a really simple calculation to figure out how much these seeds changed. So we're going to calculate a percent change in mass. Let's do that for the dry seeds first. So the equation to find the percent change in mass will be to take the final mass, subtract the initial mass, we're dividing that by the initial mass, and then we're going to multiply by 100. MF minus MI divided by MI times 100. That's going to be equal to the percent change in mass. The dry seeds ended at 5.158 grams, and they had an initial mass of 5.084 grams. 5.158 minus 5.084, that calculates to be 0.074, and then we're dividing by the initial mass of 5.084. Then we multiply by 100, and we find that these seeds have increased in mass by 1.45%. If your classroom conditions are dry, the seeds shouldn't actually change mass at all. But because my classroom is a little bit humid this past week, there was a slight increase in the mass of those seeds. Now, let's see what happened to the seeds that were in the humid conditions of the simulated burrow. Those seeds ended with a mass of 5.645 grams. They started with a mass of 5.033. So 5.645 minus 5.033. So those seeds gained 0.612 grams of mass, dividing by the initial mass of 5.033, and then multiplying by 100, we find that these seeds increased in mass by 12.16%. Now, if I were to round off, my seeds that were in dry conditions increased by 1.5%, and my seeds that were in the humid conditions of the simulated burrow increased by 12.2%. The seeds I used for this video were fennel seeds. In your experiment, you'll be using a number of other kinds of seeds, so cumin seeds, pumpkin seeds, or pepitas, coriander seeds, or whatever your teacher happened to find around that they could use for this experiment. The goal of the experiment is to determine if it matters what the macromolecule content of the seeds are. What if we have seeds that are higher in carbohydrates? See if there's a certain macromolecule profile that would provide a benefit to the survival of these small rodents, because those seeds are better at absorbing water, so when the animals eat them, that they would get more water in their diet. Thank you for watching, everyone. I hope you found this video helpful. If you're curious to learn more about rock pocket mice, kangaroo rats, and their amazing adaptations, you should check out this video right here.